Welcome to the fourth video on the mini-series developing problem-solving strategies for solving problems that use mass, moles, and molecules conversion. In this example, we are going to explore how we can use our conversion factors to determine how many oxygen atoms are contained in a certain given number of moles of O2 molecules. I encourage you guys to go ahead and start using the same procedure we have previously by writing out the pathway we need to follow. We're given in this problem a quantity of moles, right? We're given a certain number of moles of oxygen atoms. At the end of the day, a certain number of moles of oxygen molecules, rather, and we want to figure out how many oxygen atoms are contained in this quantity. So we're going to start by writing out moles of O2. Now, we need to develop conversion factors that at the end of the day gets us to the number of individual oxygen atoms. So going between moles of molecules and number of oxygen atoms is what we're after here. Now, if we look at our set of conversion factors here, we're going to see a problem. None of these conversion factors on their own will actually accomplish this task. We can see Avogadro's number here. Given a quantity in moles, Avogadro's number will allow us to convert this mole quantity into the number of O2 molecules, but not the individual oxygen atoms that we're after at the end of the day. So what we're going to need to do is actually apply two of these conversion factors. Going down our list, at the bottom here, we see we have the molecular formula itself used as a conversion factor. So it turns out we're going to have to use both Avogadro's number and the molecular formula in order to accomplish our goal. So the first conversion using Avogadro's number is going to take us from moles of that substance to number of molecules of O2. All right? Once we have the number of molecules of O2, now we can use our molecular formula to figure out the actual number of atoms of oxygen, just single oxygen atoms. So writing in the conversion factors we're going to need here, we're going to use Avogadro's number, 6.022 times 10 to the 23rd. And for our next step here, we are going to need the molecular formula itself. Okay. So for the final solution here, and our second step of the problem-solving process, we're going to plug in the actual numerical values and make sure to set up these conversion factors so that we end up with the units that we want at the end of the day. So starting off, we've got 10 moles of O2. Using Avogadro's number, we now are going to convert from moles of O2 into number of molecules, individual molecules. So we're going to want to put Avogadro's number on top, and we're going to put 6.022 times 10 to the 23rd, and that is going to be molecules of O2. All right. On the bottom, we're going to have moles of O2. So the moles of O2 are going to be canceling out, and we're going to be left, after carrying out this step in the calculator, we're going to be left with numbers of molecules of O2. Now, our second step, we need to convert from molecules of O2 over here to the number of atoms of O2. The conversion factor we're going to need in that case is the molecular formula itself. In this case, it's a relatively simple molecular formula, simply O2. So we can set up, using our molecular formula here, the fact that for every one molecule of O2, okay, there's a subscript 2 on that oxygen, which means there are going to be 2 atoms. 2 atoms of oxygen. Okay? So watch our units here. Moles are canceling out. We're left in molecules of O2. Molecules of O2, using the molecular formula conversion factor, we know that there are 1 molecule of O2. There are 2 oxygen atoms contained inside. Molecules of O2 is going to cancel out, and we're going to be left in units of atoms, individual atoms of oxygen. And so if you plug this into the calculator, you should arrive with something on the order of 1.2 times 10 to the 25th atoms of oxygen. So that's it for this sort of multi-step conversion factor. In the next video, we're going to look at how we can convert atoms and moles to grams.